All right, so notice in this problem, we're actually solving for a number. We're not finding an antiderivative. This is because we have these bounds, we have these numbers that we're going to plug into the antiderivative at the end. All right, so the way I would approach this is first find the antiderivative. So we'll have the way to do this is to write this as sine squared x times sine x cosine squared x, and then use this identity that sine squared x is equal to 1 minus cosine squared x times and now I'm going to distribute this whole thing through each of those pieces there. So we have the integral of, so my bad, there's sine x cosine squared x minus sine x cosine to the fourth x dx. Now remember, we can split this up over sums and differences, so we can think of this as that. Right, now we'll make the u substitution. U is cosine, so that du, derivative of cosine, is negative sine x dx. So that means that negative du is equal to sine x dx. So we have u squared negative du, right, because negative du is sine x dx, and those are exactly right there. And then we have minus, and we can do exactly the same thing over here. So u over on this one, we have same substitution. U is cosine. Negative du will be sine x dx. So we have integral of u to the fourth negative du. Now continuing up here, let's see, that gives us a negative antiderivative of u squared du. So I just popped that negative out to the front. Popping this negative out to the front gives me a plus, because I already had a negative out there. So I'll rewrite this with u to the fourth du minus u squared du. Now taking antiderivatives, let's see, that's u to the fifth over 5 minus u cubed over 3 plus c. Now let's see, you did that, right? And then, right, so u is cosine, that's right. U is cosine, so then now we have 1/5 cosine to the 5th x minus 1/3 cosine cubed x plus c. Right, so that's our antiderivative. That's the antiderivative. So what I found here is that the antiderivative of sine cubed x cosine squared x dx is equal to this thing. So I've now found my antiderivative. Okay, that's not the answer, right? Because we want to plug in the bounds now. All right, so then now now actually solving this problem, right? Solving this problem here. Remember, think about how you would do this, right? First you'd find the antiderivative, and then you plug in the bounds. So I already have the antiderivative there. My antiderivative, 1/5 cosine to the 5th x minus 1/3 cosine cubed x. I'm going to evaluate this from 0 to pi over 2. Now cosine of pi over 2, let's think about what that is, because we're going to need to use that here. Let's see, pi over 2, you think of start here and going pi over 2, we end here, right? So that's going a distance of pi over 2. This is the unit circle, right? So the radius is 1. So to get to this place right here, right, this is 1 here, right? So the x-coordinate is 0, the y-coordinate is 1. Where cosine is the x, and also we'll need, okay, so we have one-fifth cosine of pi over 2 whole thing to the 5th minus 1/3 cosine of pi over 2 whole thing cubed, subtract. Now we'll have 1/5 cosine of 0 to the 5th minus 1/3 cosine. Oh, thanks for that. I was worried about that, but I couldn't find my power cord and I wanted to get this video done. So anyway, for those of you that are still watching, thank you. Okay, now, so that's cosine of 0 cubed. All right, so this point here, right, cosine of 0, that's like the radians, 0 radians, right? That means we start there and we don't go anywhere. So we have 1, 0. Now cosine is the x-coordinate. So cosine of pi over 2, the x-coordinate is 0, right? So this is 0, this is 0. Here the x-coordinate is 1. So cosine of 0 is 1, so we just have a 1 here to the 5th and a 1 here. So our problem boils down to negative 1/5 minus 1/3, which is 1/3 minus 1/5, which is, let's see, it's going to be 5 minus 3 over 15 for a grand total of 2/15. All right, that's the answer.